Hello, today's video we are going to be solving systems of conics by using substitution and elimination. We've already looked at solving systems by graphing. Now we're going to do it by hand. We're going to do the substitution elimination method. We've done this method already for 2 variable systems and 3 variable systems. Now we're going to apply it to conics as well. Now when you solve using the substitution method, you're going to solve using the same steps as we did before. So step 1 of substitution is to solve for a variable. It does not matter which variables you solve for, but you want to solve for the easiest variable, and you want to make sure that you have one variable isolated by itself. So I look, and remember, the easiest variable to solve for is the one that has a positive 1 coefficient, and in this case it's x in the second equation. So I want to get x all by itself. So I've got to move that 2y squared over, I've got to move the 2 over, so we get x is equal to, that becomes a positive 2y squared, that becomes a negative 2. And the second step is to substitute that into the other equation. You want to be very careful and make sure that you're not substituting back into the same equation. If you substitute into the same equation, then you're going to end up with everything canceling out. So since we solved for x in the second equation, we're going to plug it back into the first equation. And the first equation is x squared plus 4y squared minus 4 equals 0. When we go to substitute this in, we look at the first step. We solved for x, therefore we replace x. And we're replacing x with the 2y squared minus 2. So the x is coming out, the 2y squared minus 2 is coming in. Since we are squaring x, we are squaring that quantity as well. And then everything else is going to be the same. If we had multiple x's, we'd plug it in multiple places. Now when we FOIL this, remember, this is not just distributing, you have to FOIL. You have to, remember, this is 2y squared minus 2 times 2y squared minus 2. You have your shortcut that you can use, and that's the first term squared, so that's 4y to the fourth. If I multiply these two pieces together, I get a negative 4y squared. I multiply that by 2, which is a negative 8y squared. And then I square my last term, which is a plus 4. Now, you don't have to do that. You can go ahead and do the FOIL, whichever way is easiest for you. And then we look here and we want to combine like terms. So we've got 4y squared. That becomes a negative 4y squared. Oops, that first piece is a 4y to the fourth. And then plus 4 minus 4 cancel equals 0. Now at this point we need to solve. We have many different methods of solving. At this point, you have to take in everything that you know about solving. What's the easiest way? We know a method of solving is factoring. We know a method of solving is the quadratic formula, but that's only for quadratics. We know that we can use solving by completing the square. There's so many different methods, and you're going to have to really look at the problem and make the best judgment of what you should do. When I look here, I'm going to start by factoring. And let's go ahead and move this over. And when I look, the GCF is a 4y squared. I pull that out of the first one, I'm left with y squared, and I'm left with minus 1 equals 0. I look on the inside, and that's the difference of 2 squares, so that's y plus 1, y minus 1. So when I solve for y here, this gives me a solution of y equals 0. This is y equals a negative 1. And y equals a positive 1. So I have 3 possible values for y. Our last step, step 3, is substitute into step 1. So we found 3 possible values. We've got to plug all 3 of those in. So step 1, we had x is equal to 2y squared minus 2. You could really substitute this back into either one of the original equations as well. I just like step 1 because it's already solved for x, and that's what we're looking for. So our first possible y value is 0. So that gives us a negative 2. So from this point right here, we used y equals 0. We found that x equals a negative 2. So our solution is a negative 2, 0. Then we check a negative 1. x is equal to 2 times a negative 1 quantity squared minus 2. Well, negative 1 times negative 1 is a positive 1. 1 times 2 is 2 minus 2. X equals 0. So when I put the y value of a negative 1 and the x value of 0, I end up with 0 comma negative 1. And then last, we plug in when y is 1. So x equals 2 times 1 quantity squared minus 2. 1 squared is 1, times 2 is 2. 2 minus 2 gives us x is 0 again. So this solution is at 0, a positive 1. So for this first problem, we have 3 solutions solving our substitution method. All right, now our next method we could use to solve is the elimination method. In the substitution method, when you're using that one, you want to make sure that you can isolate one variable. In the first one, we isolated x, and we only had y's on the right-hand side. When you're eliminating, you want to make sure that you're eliminating everything. So if you choose to eliminate the x's, you better get rid of every single x. If you eliminate the y's, you make sure that all y's are gone. So you want y squared's gone, you want y's gone. When we look at the first equation, we look to see if anything cancels. Well, we've got an x squared and a negative x squared. But when I look to see what's left, I've got y's and I've got x's. That doesn't work for us. We want to make sure that if I'm going to eliminate the x's here, I'm eliminating the x's here as well, and that's not happening. So when you have x squareds and x's, you can't eliminate them. So what my goal is I'm going to look to eliminate the y's. So since I have a positive y on top and bottom, I'm just going to multiply one of my equations by a negative 1. I'm going to choose the bottom equation. So the top equation doesn't change, so we recopy that. The negative negative becomes a positive x squared. That becomes a negative y squared, a negative 9, and it's still 0. So now x squared and x squared gives us 2x squared. A positive y squared and negative y squared, that's canceling. That's the only, oops, that's squared. We only have the one x term, so that's just a negative 16x minus 9 is equal to a negative 39. So when you're using the elimination method again, when you're at this step, you want to make sure that you're only left with one variable. I should not still have x's and y's down here. When you are eliminating, make sure that you're only combining like terms. So I couldn't combine the negative 16x and the negative 9 because one has an x and one's just a number. So it's going to be a little bit different looking than what we're traditionally used to seeing with the elimination method. So we look here. I'm going to try to factor because factoring is the easiest way to get rid of or to solve for an x squared. So I'm going to move that 39 over. So we've got 2x squared minus 16x. So that means I would be adding 39, which means I have a positive 30 left. First step of factoring, always take out that GCF. So we've got x squared minus 8x plus 15 is equal to 0. So we're looking for two numbers that multiply to 15 and add to a negative 8. Those two numbers, well, if we're multiplying to a positive and adding to a negative, the only way to get that work is if they're both negatives. And the two numbers would be a negative 3 and a negative 5. So now we want to solve for our possible values. If I set 2 equal to 0, there's no variable, so there's no solution. So I have a possibility when x is 3 and when x is 5. So there's two possible values for x. Now we have to find out what our y values are going to be. We're going to go back to our equation, and if we're solving for y, I'm going to just pick the first one. It does not matter. So we have our second equation, or our second step. We're going to plug back into our first equation. And we have our first possibility of when x is 3. So we've got 3 squared plus y squared minus 16 times 3 equals negative 39. So that's 9 plus y squared minus 48 equals a negative 39. A positive 9 and a negative 48 is going to give us a negative 39. We move that over. Y squared is equal to 0. Square root, the square root of 0 is 0. So we have when x is 3, y is 0. So our solution here is at 3, 0. And our last one is when x is equal to 5. So we've got, again, we have our equation up here, so that's 5 squared plus y squared. We're trying to solve for that y. Minus 16 times 5 equals a negative 39. So we've got 25 plus y squared minus 80 is equal to a negative 39. We have a y squared minus 55 equals a negative 39. We move that 55 over. Y squared is equal to 16 square root. And we have two possibilities here, a positive, negative 4. We didn't have that possibility up here because 0 is neither positive nor negative. So we've got plus or minus 4 when x is 5. So I could have 5, 4, or I could have 5, negative 4. So this one, again, is going to have 3 possibilities. All right, let's turn over to the back page. We only have 2 problems left. I know we only done 2. This time I'm not going to tell you which method to use. We look at the first one. 5x squared plus 3y squared is equal to 17. And we've got a negative x and a positive y is equal to a negative 1. You've got to think which one is going to be better, the substitution method or the elimination. If I'm using substitution, I want to be able to isolate one of my variables and only one. If I'm using elimination, I want to be able to get rid of all of my x's and all of my y's. So stop for a second and think about which method would be the best method for this first problem here. When I'm done thinking about it, if I tried to eliminate the x's, if I multiplied this through by 5, well, I'd be left with a 5x squared, a negative 5x. Those don't cancel because this one is squared and this one is not. So if I try to fix that problem and say, okay, that's fine, I'll multiply by a 5x. Well, then I get a negative 5x squared. Fixes that problem. But then in my second piece, now I've got a 5xy. Now I've got a whole new kind of problem. So hopefully after a couple seconds, you realize that for this first one here, you have to use the substitution method. You are not able to solve this one using the elimination method. So I want you to press pause, and I want you to go ahead and go through and solve this one using the elimination method. All right, let's see how you did. The easiest variable to solve for would be y in the second equation because it has a positive 1 coefficient. You could have also solved for the x, but I would have solved for y, which I did. So y, when I move the x over, becomes x minus 1. Step 2. Since we solved in the equation for the second equation, I'm going to substitute that back into the other equation, which would be equation 1. Since I solved for y, I'm going to replace y, and y gets replaced with the x minus 1. Again, you're squaring that quantity, which means you are foiling it to get x squared minus 2x plus 1. Then you distribute the 3. The 3 is not being squared here, only the y. So you FOIL the x minus 1, and then you distribute the 3 throughout. Then you combine your like terms to get 8x squared minus 6x plus 3. Move the 17 over. You do look and you do have a GCF. You can pull a 2 out. However, after you pull the 2 out, you now have to use the Batman factoring method in order to factor. So yes, Batman's going to come back up. Completing the square is going to come back up. Quadratic formula is going to come back up. All of those different methods to solve a quadratic could be used. So when I'm done factoring, I get my GCF of 2 times, I use the GCS for my group factoring. X plus 1 is my first factor, 4x minus 7 is my second factor. No variable, no solution. So I have 2 possible answers for x. X is a -1, and x is equal to a +7/4. And then the last step of substitution is we're substituting that back into step 1. In step 1, I solved for y, saying that y was equal to x minus 1. Well, I plug a -1 in. -1 minus 1 is -2. Since I plugged in a -1 for x, I get a -1, -2. Well, my other possibility was 7/4. So 7/4 minus 1 gives me 3/4. So therefore, my second answer is 7/4 and 3/4. So this problem only has two possible solutions. And our last one, when I look at this one, obviously we just use substitution. So what I want you to do is use elimination on this second one. Think about which variable you should be eliminating. Should you be eliminating the x's or should you be eliminating the y's? I'm going to leave that up to you, so press pause and go ahead and solve this one. Alright, so let's check our very last one. I eliminated the x's. The reason why I chose to eliminate the x's and not the y's is because the x's only had x squared. So when I looked at the y's had y squareds and y's. So you wouldn't have been able to eliminate your y's. So you've got to eliminate the x's. So you choose to either make the top or the bottom negative. I chose to make the top negative. So the x's canceled out. Now when you're doing your linear combination, which is another name for the elimination method, make sure that you're only combining like terms. So after my x's canceled, I look at all my pieces. I've got the 3y squared. Then I've got a y here, a negative y there. That gives me a -3y, a +4, a -10. That gives you a -6. You're used to having everything lined up, so you don't have to worry about combining like terms. When you have these conics, you're not always going to have things lined up, so you want to make sure that you're just combining your like pieces. Then I pull out my GCF of a 3, and I factor. So I get two possibilities for y. Y is either 2 or y is a -1. I'm going to go back and I can substitute back into either one of my original equations. If I have values of y and I'm trying to solve for x, I look at the first equation, I only have one y I'm substituting in. When I look at the second one, I've got y squareds, I've got y's. This equation looks a lot more complicated, so I'm not going to use the second one. I'm going to actually plug back into the first equation. So I go back, the first equation is x squared minus y minus 4. And we have these two possibilities. We have where y could be 2. So I plug in 2 for y. I get a -6. I move to the other side. So I've got x is equal to plus or minus the square root of 6. The y value that I plugged in was 2. So 2 is the y coordinate. I could have a +6, a positive root 6, or I could have a negative root 6. So when y is 2, I have two different possibilities. Then we could also have when y is a -1. So I plug a -1 in. Minus a -1 means a +1. So I've got a -3 there. Move it over, plus or minus the square root of 3. And I get these x coordinates for when y is a -1. Therefore, -1 is the y coordinate for both of them. One's a positive root 3 and one is a negative root 3. So this one is going to have 4 solutions. Remember, solutions are also intersection points on your graph. You should be able to give me the exact answers or rounded answers. So all I have to do is plug root 6 into your calculator and give me the rounded answer. And you are finished for today.